If you remember when we did double triangles before, it's all about problem solving. So we're being asked to find x, but we're not given any information to be able to find x directly. So we got to find other stuff first before we can find x. And so we have to do things like, what can I find with the information that I have? What would be useful? What would I need in order to find x? A lot of people, and I felt like a lot of you were very good at it the first time around, so that's great. What was I going to say? I think a lot of people have a gut kind of feeling about it, and that's fantastic, but it is kind of useful to think more explicitly. So for example, in this question, what would I need to find x? What would be helpful? What would I need?
The bottom, or like the side of the shape.
So a length, like maybe this one, if I call this A and I call this B, something like that, one of those two. Anything else? If I had A, would I be able to find x? Very good. So that's a big part of mathematics, and I think we take it for granted sometimes, and probably all of you are able to do it, but recognize that we'll use a formula. Let's say I get B, and this I'll end up using sine equals opposite over hypotenuse. So I'm going to use this formula, and this formula has 3 variables in it. So in order to use this formula, I need 2 of them, and I can solve for the third, and that's what we did in all of this SOHCAHTOA stuff. So I need, in order to find x, which would be the opposite, I need theta, so an angle, and hypotenuse, so a side length. With right triangle stuff, if you have 2 side lengths, you can find an angle. If you have an angle and a side length, you can find another side length. And you can basically find any side length by setting it up properly, right? So that's some of that stuff you're doing automatically. You might not even be aware that you're doing it, I would think. I would wonder. And that's fine. It's better if we're aware of the things that we're doing. But anyway, so in this case, and we've done this before, but now we have sine law and cosine law. Like I said, it adds more interesting kinds of diagrams. And we're going to, especially when we start applications tomorrow and the next day, there's a couple of applications that I think you could see how they're actually very useful, and you can imagine people actually using them. It might be technology doing the math in the background, but people who work like everyday jobs would be using this kind of math, or the technology that they use would be using this kind of math. So it's kind of interesting, I think. Trigonometry, when you're doing triangle trig, it's easy to see these real life applications. That's why I think that makes it easier for some students and makes it interesting. So what do you think we should find? So Zach, you said we could find either this side length, I'll call it A, or this side length, I'll call it B. Which one, can we find either of them? Or what can we find? Jada? Okay, great. So first of all, I got to find this angle. And did you do that already? What is it? So we get 37 down here, and we're just going to write it in. I'm not going to ask you to show that step. You can just do it on your calculator, but I want you to write it in, and you show me that you did calculate it, okay? And then these wedge triangles can be tricky, but 37 is across from B, and then I have this side length of 30, which is across from 8, I think, right? So then I can use sine law to find B. And this is sine law because I have 2 angles and any side, if you remember that sine law. So I'm going to use sine law. So 4B. And I'm going to get B over the sine of the angle across from it. And I'm starting with I'm looking for a side length. I'm looking for B. So I'm putting B on top. It makes your life easier if you always start with the variable on top, because we can choose. Some formulas just are the way they are, and you're stuck with them. But some formulas we can kind of decide a little bit, right? And then equals, so I got to have all the side lengths on top. So I'm going to go with my side length on top. and then sine of the angle across from it on bottom, which is sine of 8. And then I want to see this rearranging step as well. Ooh, telephone. Okay, and try putting that into your calculator to see if you can get the right answer. It's a lot of this with calculators. Color? Okay, bye. And what do we get?
130.0.
Nice. B equals. Well, I'm gonna. So, did you get 129 point something? Yeah, and it rounds up to 130. Okay. But I'm gonna keep a whole bunch of decimal places, and I'm gonna actually show you what I'm gonna do. So I'm gonna write down 4 decimal places. 4 is probably excessive, to tell you the truth. We probably don't need 4, but I'm gonna go with 4 anyway, just to be safe. That's sort of my rule of thumb. If you choose to do something different, then you are taking your own future into your own hands, and that's fine. You'd probably get away with 2. 3 would almost be certain. For some reason, when I started doing this, I always use 4, so I just kind of still do. All right, so I've got my calculator ready because there's an even easier way, I think, to make sure that your answer is perfect. And so I think some of you probably already know this, but there's always somebody who doesn't. So we're going to do it anyway, and I'll show you on my calculator how it all works. So I'm going to do it this way: 30 sine 37 over sine of 8 equals. So I got 129.7266. So I did round that last one. Okay. Now, we already talked about this. Now I have B, and so it equals about 129.7. And I can use that. Oh, actually, I can't yet. What do we have to do first? There's one more little thing.
Define the angle.
Do you know how to do that? This bottom one, right?
Yeah, because it's on a straight line, it equals 180, so 135.
Yeah. So 180 minus 135 will give you this value, and that works out to be 45. Did anybody check that already? Did you do that already? 45, right? So I chose not to use my calculator because I want this answer still sitting on it. You could do the 45 first, or you could redo this one to have that answer, but it's 45. So now I'm doing B is my hypotenuse because it's across from the right angle. And I'm using 45. Something that's interesting now in this case, well, this is a bad example. I'll talk about it after. 45 would be a bad one to use. So across from 45 is x, so that means I'm using sine. Sine is opposite in hypotenuse. So 4x, I get sine theta equals x over b in this case, right? And so sine 45 equals x over, and I don't, every time I sub this in, I wrote down 4 decimals here, but I don't need to write down 4 decimals every single time, okay? I'm fine if then you go 129.7. I'm going to write that there, okay? I move that over, rearrange, whoops, 129.7 sine 45 equals x, and x equals, and here's what I'm going to do. On my calculator, I'm just going to do the answer. So I've got this answer button, and that pulls up the answer that I just did with all the decimals, not rounded to 1, not rounded to 4, all the decimals, times sine of 45 equals, and I get an exact answer, and that's x. That's what we were supposed to find. It said round to 1 decimal place, and now I can round to 1 decimal place. So almost all of the time, or I should at least say a lot of the time, you can just keep the answer stored in your calculator and use it for the next thing that you're going to find. And so you don't have to round at all, okay? But if you do have to round, keep more decimal places and use them, punch them back into your calculator. If I did this, I think in this case, let's see. If I used 129.7 times sine of 45, let's see how the answer is different. I would still get 91.7. My answer would be the same rounded to one decimal place. Often that will happen, but not always. And it's impossible to predict when that will happen. So that's why we keep extra decimal places. All right, let's try the next one. Same thing. We got to develop a plan, problem solve, think about what we have, what we can find, what we would need. X is in the right triangle again. What did we just talked about this? I've already got an angle, so all I need is a side length. And very often, and I think most of you know this, the side length you're going to find is the one that they share. I don't know how I could find that side length. I don't think that would really work, would it? So we're going to find this one, so I'm going to call it Y. And what am I going to use? This is not a right triangle, so I'm not using SOHCAHTOA. So what am I going to use to find Y? Who knows? It's going to be sine law or cosine law. Sarah? Why do you think? Right, two sides and the angle between them is cosine law. So 4y, and it's this version. I'm looking for a side length, so it's this one. Y equals the square root of 25 squared plus 32 squared minus 2 times 25 times 30 times the cosine of the angle between them. And since I wrote it down that way, I don't have to rearrange. I can just punch it into my calculator. Cos 125 bracket. 50.6628. Again, keeping 4 decimal places where possible. And now this one's pretty easy because I've got an angle and I've got a side length, so I can just go ahead and find X. And right triangle, so I'm using SOHCAHTOA. And on this one, I'm going to use cosine. I want to point out what a few people did on the quiz, a mistake that they made. I'm going to keep that answer, so I want a different calculator. So I'm going to do 180 minus 90 minus 62 to find that other angle, just to demonstrate what some people did and a mistake that they made. So this one is 28. And a lot of you like to do that and then like to use that angle instead of the one that you're given. And in this case, it's fine. They're both exactly accurate, so you're not going to get a different answer. But this is what people did, is they labeled the triangle for the 28, but then they used the angle 62 in the question. So if I label the triangle for 28, then this is opposite, and I would be using sine. So you used sine, but then you put 62 into your equation, and so your answer is wrong. So be really careful of that. When you label your triangle, or when you're picking which one, like I chose cos, but it's not cos of 28 equals x over y, which is 50.7, right? Because 28 is opposite of x. If I choose cos, I need to make sure I'm using 62 so it's adjacent. So when you get your, so I'm going to fix that, 62. When you get your quizzes back, or we'll do a learning goal tomorrow, or as you're working, really be careful and think about that. And that's why, again, even though you can use either of the angles, I always just use the one that's given. So I like think about the sides in relation to the 62 in this case, and I don't even worry about 28 because I don't need it, so I don't want to confuse anything. 50.7 cos 62 equals x, so x equals, and now I can round to 1 decimal place and back to this calculator, and I don't even have to hit it. I'm sure you've noticed this, but if I just hit times, it puts answer in there for me, right? So times cos 62, 23.8, rounding to 1 decimal place because it's my final answer, and that's centimeters. Is that a reasonable answer? Why or why not?
Can't really tell because the one triangle is not any other side.
That's true. Yeah. But like, if I got a number like 10,000, would you think that's reasonable? No. So I think, like Zach's right, you can't really tell for sure, but it's at least in the ballpark of the other ones that I was given. Sometimes with trig, if we punch something in wrong, you get like 0.936 or something, right? And that's not going to be right. So you can tell. I would say it's reasonable enough because it's in the ballpark of the 2532. Again, like if I even got an answer like 100 or 80, I would think, that doesn't look right. Any questions about that one? We got one more to do. Yeah, after the lesson, not right now. All right, this one has no right triangles. It's all SOHCAHTOA, or no SOHCAHTOA. It's all non-right triangles. What do you think? This one's a little bit trickier. What was one of the other strategies we talked about when we did this the first time is you may not know right off the start exactly how this one is going to work. Like you may know, I'm going to do this, then this, then this, then this. Some of them you do. You're like, oh, I'll use sine law for this, and then I'll be able to use SOHCAHTOA for that to find that side, and then I'll be good. But sometimes you can't. This might be one of those times. So a strategy is just find what you can. Solve for what you can find.
You use sine law to find the angle at the bottom, and you can do 180 minus that to find the other one, and you can find the side that they share.
Okay, very good.
Find the top angle, right?
So in the bottom, hold on, in the bottom triangle, you noticed that you have an angle and a side length across from it, and one other measure, so you're using sine law. And what am I going to be able to find with that, though?
The angle in that triangle.
This one, right? Which isn't all that useful yet, is it? So yeah, that's good. So, but this is all I can find, so that's what I have to find. And then what Zach said is then you can find that angle, and that's useful. And why is that useful? Then we can find this side, we'll call it y, and then I've got enough information in this triangle to find that. What's the other thing that you could find? I could find this angle up here. It works out to 57, and I think we're going to need that eventually anyway. If you did that first and you didn't realize that you're working in this triangle, you wouldn't get very far because you'd get to 57 and you'd kind of be stuck there, right? So we'll use sine law, and I'm going to call this theta. So 4 theta. Sine theta. So I'm looking for an angle. It's always sine of the angle. So I'm going to put that on top and go across, and I find 142 there. So 142 equals, and again, keep the angles on top. So sine of the angle, which is 71, over 162. Rearrange. Shift sine 142 sine 71 over 162. So again, I'm going to keep extra decimal places here. 55.9744. You can use whatever variable you want I'm going to use alpha. That's a alpha symbol, another Greek letter that we often use. And so for alpha, it equals 180 minus 71 minus that 55.97, so 55.97. I'm not going to write it all down though. And that works out to, so again, watch me on my calculator. 80 minus 71 minus the answer that I had. So I'm going to keep a perfect answer doing that. 53.0256. Now what am I going to use? Now I can find y. What am I going to use to find y? Nick, do you have an idea?
Oh, you can use the two sides and use the fraction alpha.
Yeah. Good. So sine law or cosine law? Sine law? You can, that's true. Actually, I was thinking cosine law, but you could use either. So if I'm using sine law, I'm going to use, let's say, 71 and 162 because they're given to me, and then that guy alpha and find y. But could I also use cosine law because I've got two sides and the angle between them? So you could do either. So if you want to do something different, I'll do sine law because that's what Nick said for y. So y over sine of the angle across from it, which is that one we just calculated, alpha, so sine of 53, equals 162 over sine 71. (162) sine, now the 53 is the answer that I have in my calculator, divided by sine of 71. (8,799). Lots of steps in this one. And finally, I think we can find x. But again, I had to find that 57 because it's across from the y. And then for x, I'm going to use the 41. Equals y, which is the 136.9 over sine 57. So there's my 136.9. So I go times sine 41 bracket divided by sine 57 equals 107.1. And that's meters. I had a conversation, we talked about this a little bit last week, but I had a conversation with somebody, I can't remember who it was, but it was somebody in here, about like rounding and why it matters. So I don't know, if we had just rounded all of those answers along the way, all these angles, I'll tell you this, often when you round an angle and then use it, that's going to change your answer quite a bit. So I wouldn't be surprised if we were off by more than a little in this case. But if I had rounded all of these all along the way, I wonder how far off from 107.1 I would be. And like, who cares? Like all this talk about the calculator, and I mean, it's useful trick to use your calculator, the memory function and the answer button on the calculator. It can be really, really useful. And if any of you take any college program or university program that has some calculator work, you're going to find that to be really useful. In fact, it has these calculators have a lot of memory, and if you learn to use those, it can be really helpful. But anyway, I think it's a useful trick, so it's good to talk about because of that. But I also think, we might not really care how accurate that 107.1 is, but we should know that an answer is accurate or is not accurate, and how accurate is it? That's something that we should know when we're calculating things. When is it okay to round? Because it doesn't really matter. We talked about this. If you're working with wood, it doesn't usually matter if you're off by a little bit. Wood's very forgiving that way. But if you're making things out of metal, or if you're making some like jewelry or something like that, and it's especially if it's expensive and fancy, you need things to be exact. And they have machines that cut like really, really, really accurately for those kinds of cases. Or like I think I talked about the example of making a spaceship, something like that. So it's just, I think it's important to know when your answer is perfect and when it's not. And so this is just a good moment for us to be able to practice using our calculator perfectly. I think I can quickly check. So I'm just going to do that. 180, if I rounded it to 56, I'd do 180 minus 71 minus 56. And I get 53 instead of 53.0026. And then I used that to find y. So instead of, where is it? There it is. So 162 times the sine of 53 divided by sine of 71. So how much is that off by? 136.8. 0.83 instead of 87, so it's not too much. And then I'm going to go, but if I rounded that again, 136.8 times sine 41 divided by sine 57. Let's see. Yeah, 107.0 instead of 107.1. I mean, that's 10 centimeters because you're talking meters, so that might matter. 10 centimeters might matter. But again, it's just something that's good to think about once in a while, I think.